Greetings everyone, and welcome to my channel. In this video, we are going to talk about k-nearest neighbors. K-nearest neighbors is a simple yet powerful classification algorithm in machine learning. It makes predictions based on the similarity of the data points. K-nearest neighbors determines the class of a new data point by considering the class of its nearest neighbors. For example, if we have a data which has two categories, A and B, in this case, we have two different clusters, A and B. But what will happen if we receive a new data point? Will it be clustered as A or as B? It may be clustered as group A. That's what k-nearest neighbors decides. As another example of k-nearest neighbors in biology, the k-nearest neighbors can be applied to classify different species based on their characteristics. For instance, consider a dataset containing measurements of various flowers, such as petal length and width, and their corresponding species label. We can use the k-nearest neighbors to classify a new flower based on its measurement by finding the k-nearest neighbors in the dataset and assigning the majority class or species among them to the new flower. As here we can see, based on the k-nearest neighbor, the red X will be defined as white flower. The k-nearest neighbors algorithm can be considered both as supervised and unsupervised machine learning model, depending on how it's used and the context in which it is applied. Imagine if we are in a zoo and we want to sort these animals. In the context of supervised machine learning model, the k-nearest neighbor is typically used as classification algorithm given a labeled training dataset with input features and corresponding class labels. It makes predictions by assigning the class label that is most prevalent among the k-nearest neighbors of a given test instances. Based on the sorting, the bees are alone, birds are alone, dogs alone, and dinosaurs are alone too. On the other hand, in the context of the unsupervised learning, the k-nearest neighbors can be used for tasks such as clustering and density estimation. In the clustering, k-nearest neighbor algorithm can group instances based on their proximity, where the value of k determines the level of granularity in the clusters. As we can see here, based on the unsupervised machine learning model or clustering, we have two clusters. Density estimation involves estimating the probability density function of the data based on the distribution of the k-nearest neighbors. Therefore, k-nearest neighbors can be applied as a supervised learning algorithm for classification tasks, where the class labels are known, or as unsupervised learning algorithm for tasks like clustering and density estimation, where the class labels are not available or not utilized. Now let's implement the k-nearest neighbors examples in Python for a supervised and unsupervised machine learning models using the scikit-learn library. The first example is for the supervised machine learning model. In step 1, we import the necessary libraries including NumPy for numerical operations, k-neighbors classifier from scikit-learn for k-nearest neighbors modeling, train test split for data splitting, an accuracy score for evaluating the model's accuracy. In step 2, we create a simple dataset with two independent variables x and binary dependent variable y. In our case, we have x as a 2D array representing features, and y as an array indicating classes 0 or 1. In step 3, we split the dataset into training and testing sets using the train set split function. This step randomly splits the data into training and testing sets with 80% for training and 20% for testing. In step 4, we create an instance of the k-nearest neighbors classifier class and train the model using the fit method. Set the parameter k to the desired number of neighbors to consider. In step 5, we use the trained model to make predictions on the testing set using the predict method. Step 5, make predictions. In step 6, we evaluate the model's accuracy by comparing the predicted labels y_predict with the actual labels y_test using the accuracy score function. The accuracy score function from the scikit-learn is used to compare the predicted labels in y_pred with the actual labels y_test. The accuracy score function calculates the accuracy by counting the number of correctly predicted labels and dividing it by the total number of labels. In our case, the accuracy is equal to 1. It means that all predicted labels matched the actual labels, resulting in a perfect classification performance on the test data. In other words, the model made no errors in predicting the labels for the given test dataset. Now let's plot our data. H equal 0.02, which is the step size in mesh that will be used to create the decision boundary plot. And then the minimum and maximum values for x and y axes are determined based on the minimum and maximum values of the features in x. H equal to 0.02, this line defines the step size in the mesh. It determines the spacing between the points in the grid used for visualization. In this case, the step size equal to 0.02. Xmin, Xmax. These lines calculate the minimum and maximum values of the first feature x. The values are then adjusted by subtracting 1 from the minimum and adding 1 to the maximum. This ensures that the entire range of the feature values is covered in the visualization. And for ymin, ymax, similar to the previous step, these lines calculate the minimum and maximum values of the second feature. The values are adjusted by subtracting 1 from the minimum and adding 1 to the maximum. Then we create a mesh grid using np_meshGrid function to generate a grid of points within the range defined by the minimum and maximum values. xxyy np.meshGrid. This line creates a mesh grid by using the np_meshGrid function. It generates coordinate arrays x and y that span the range of feature values with a step size of h. The np.arrange function is used to create evenly spaced values between xmin and xmax for the x coordinate and between ymin and ymax for the y coordinate. The model's predict method is called on the mesh grid points numpy.c xx_ravel yy_ravel to obtain the predicted class labels for each point. G equal to model.predict numpy c xx_ravel yy_ravel. This line predicts the class labels for each point in the mesh grid. numpy.c function is used to concatenate the flattened xx and yy arrays column-wise, creating a matrix where each row represents a point in the mesh. The predict method of the trained k-nearest neighbors classifier model is then used to predict the class label for these points, and the result is stored in the z variable. The reshape function is used to reshape the predicted class labels array z to match the shape of the mesh grid xx. We imported the matplotlib in order to plot our figure. Then the contour function is used to create a filled contour plot based on the predicted labels. This represents the decision boundary. The filled contour regions in the plot represent the decision boundary of the k-nearest neighbor model. Each region corresponds to a predicted class based on the model's classification rules. The contour lines separate the feature space into different regions, where each region is associated with a specific class label. The color of each region indicates the predicted class for that region. The plot helps us understand how the k-nearest neighbor model classifies new data points based on their proximity to the training data. The decision boundary visually shows how the model separates the feature space into regions associated with different classes. Any new data point falling within a particular region will be assigned the corresponding class label. Now let's implement another example for unsupervised learning regarding clustering. Then we generate a random dataset. After that, we create a k-nearest neighbors model for unsupervised learning. And then we find the nearest neighbors of each point. After that, we print the indices of the nearest point. In the unsupervised learning example, we use the nearest neighbors class from the scikit-learn to find the nearest neighbors of each point in a randomly generated dataset. We specify the number of neighbors to find k equals 3, fit the model on the data, and then obtain the indices of the nearest neighbors for each point. After that, we make a chart for the k nearest neighbors. And now we plot the data points. After plotting the data points, we have to plot the nearest neighbors. Now let's plot the k nearest neighbors. And here we have it. In this code, we used nested loops. We iterate through each point and its corresponding nearest neighbors. For the command plot xi0, xj0, xi1, xj1, this code plots a line between the current point and its nearest neighbor with red color. We made a visualization of the randomly generated dataset with lines representing the connections between each point and its three nearest neighbors. The purpose of this visualization is to depict the concept of nearest neighbors and demonstrate how the k-nearest neighbors algorithm identifies and connects neighboring points based on their proximity in the dataset. By visually inspecting the plot, we can observe the clustering or grouping patterns of the points and the relationships between neighboring points. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel, hit the like button, share the video, and leave your comment under the comment section. Until next time, happy analyzing.